So in this video, we're going to take a look at rational exponents with signed numbers as bases. So we've got a variety of different kinds of signed numbers, some in parentheses, some not in parentheses. We've also got a bunch of different exponents. So we've got thirds, fifths, halves to the fourth. And I've got these divided up because we want to deal with these in a specific way. So we're going to treat the odd number roots, so our 1/5, our 1/3, those are going to be treated the same. And then our even roots, those are going to be treated the same. So 1/2, 1/4, 1/6 if we went up further. So that's why I have them grouped the way that they are. So the first set here is that we've got -125 to the 1/3 power. So we can always rewrite this if we want as the square root of -125, not the square root, this is the cube root. Sorry about that, this is the cube root of -125. So we're looking for a number that we can multiply by itself 3 times. So what can be multiplied 3 times to get -125? And our answer is -5. So if we do -5 times -5 times -5 multiplied by itself 3 times. So our first set of numbers are -5 times -5, that gives us 25. Then times one more -5, that gives us a -125. So we can do that, we get a real number for our answer. And then we've got this one here without the parentheses. When there's no parentheses, what that really means is that we've got a -1 times 243 to the 1/5. So when it's not in parentheses, we need to do that negative after we take our root, which it's not really a big deal. This just becomes the -1 or a -1 times the 5th root of 243. So we're looking for what number do we multiply by itself 5 times to get that positive 250 or 243, excuse me. And in this case, it's going to be 3. 3 times 3 times 3 times 3. That's going to give us 9 times 3 times 3 times 3. So we could do another 9 in there times 3. So we get 81 times 3. And that's where we get the 243 times 3. So our solution is -1 times that 3, which also gives us -3. So with an odd root, when it's something like a 5th root or a 3rd root or a 7th root, it doesn't matter where those parentheses are. If our negative is inside of our root or if our negative is outside of our root. It doesn't matter at all because we can take the cube root or the 5th root or the 7th root of any number. So that's kind of our takeaway statement from these first guys here is that we can take an odd root of any number we want. Positive, negative, doesn't matter. With our even roots, so our 1/2, our 1/4, there we've got a little bit more of an issue. So when we're looking at -64 to the 1/2 power, this is square root of -64. So it's asking us, is there a number that we can multiply by itself and we get -64? There's not. So this is not a real number, at least not in the real numbers, not what we're dealing with right now. So this is not a real number. We cannot do this. And that's because if we had +8, that's +8 times +8, we get 64. If we tried to say, oh, well, maybe it's -8, that's our answer, then we get -8 times -8, which is still +64. So there's no two numbers that are exactly the same that we can multiply together that give us that -64. Now you might know what to do with this with imaginary numbers, but don't worry about that right now for this problem. We just get to say this is not a real number. Now, when we look at the next one, this negative 81 to the 1/4, because we don't have it in parentheses, and this is the whole big difference, is that here we have parentheses, here we don't have parentheses, and just like up above, when you don't have parentheses, this is really -1 times 81 to the 1/4 power, or -1 times the 4th root of 81. And what this all comes down to is order of operations. When we have it in parentheses, the parentheses tell us to make it negative first, and then do our exponent. When we don't have parentheses, here it says do the exponent first. That's the whole difference between these two. So here we're looking for something that we multiply by itself that gives us 81. We actually know what it is from up above, that it's 3 times 3 times 3 times 3, because that gives us 9 times 9, which is 81. So we get -1 times 3, and we get -3 as an answer. So it's totally okay if we have that negative out in front, as long as we're not in parentheses. The minute we put it in parentheses, we make it negative, we make our base negative first, then we're taking our root. We can't do that with our even roots. So our takeaway here for even roots is that we can only take the even root of non-negative numbers. And the other important takeaway from this is really the difference of when we have a number inside of our parentheses, if it's got a negative in there, in the parentheses with the exponent, that is raising a negative number to this power, or taking the root of that negative number, however you need to think about it. But when we have negative b to the x, that is multiplying b to the x by -1. And it really is, it goes back to order of operations. When it's inside of that parentheses, we make it negative first. When there's no parentheses, it does split this up as this is -1 times b to the x, and we do our exponent first and our multiplication second.